Payne Institute for Public Policy podcast. I'm Ashley Spurgeon, editor of Mines Magazine at Colorado School of Mines. I'm joined by Gregory Clough, Strategy and Operations Manager for the Payne Institute, to talk about the current energy transition, its effects on STEM education, and the future of energy innovation. Hi, Greg. Thanks for chatting with us today.
Thanks for having me, Ashley.
Also joining us is Michael E. Weber, the Josie Centennial Professor in Energy Resources and Professor of Mechanical Engineering at the University of Texas at Austin, and the Chief Science and Technology Officer for the Global Energy and Infrastructure Services firm, ENGIE. Hi, Michael. Thanks for joining us today.
Thank you very much. It's good to be on the line with you.
Michael, I thought we could start off by talking about your latest book, Power Trip. For listeners who may not be familiar with the book, it examines humanity's relationship to energy over time, calling energy humanity's most important resource. When I read this book a few months ago, I thought it provided some helpful context and perspective on the current energy transition we're facing. Michael, very early on, you say that the goal of the book is to demystify the magic of energy and to celebrate its transformative power. What inspired you to write this book and tell the story of energy starting from a historical perspective?
The motivation to write the book is really to introduce energy to a lot of people who aren't aware of it, even though their lives are surrounded by energy and they're touched by energy in many ways. I like to say that energy is hidden right in front of our eyes. And so what I want to do in the book is peel back some of those layers and reveal it to people in a way that's accessible, interesting, and hopefully useful. Because when it comes to the future of energy, we all have a stake in the outcome. We're all decision makers that affect what kind of energy impacts we'll have or what kind of sources are available. So it's good for us all to improve our energy literacy, and books are one way to reach a different audience.
Great. Now, Power Trip details several energy transitions that have happened throughout history. So the transition to less carbon-intensive materials we're experiencing now isn't a new phenomenon. Can you expand on this idea that energy is always transitioning and how we must always look for new ways to meet our energy demands?
Yeah, sure. See, I guess the point I'm trying to make, and other people in the field make the similar point, which is that the only constant in energy is change. There's nothing that really stays steady. It's always in a state of flux. It's always transitioning. And there are a couple examples from history where we can point to that look familiar to what we're going through today in terms of some of the trends and the indicators, and perhaps offer some lessons learned. We went from wood as a dominant fuel in the United States, for example, to coal as a dominant fuel. Coal overtook wood in 1885, and then petroleum overtook coal in 1950. Petroleum is still dominant today, although natural gas might overtake it in the next decade or less. So we've been through these transitions, at least in terms of what the dominant fuel is, from wood to coal to oil, and perhaps natural gas, and I don't know what's next to that, maybe nuclear renewables. And that reveals that we can do this, we have done this, and mostly it's been good for us because we've gone from dirtier to cleaner fuels. Oil is cleaner than coal, and actually coal is cleaner than wood in terms of carbon emitted per pound of fuel. So there have been some benefits along the way, but there are other lessons learned, which is it takes a while, so we better get started. And the other lesson is that yesterday's solution might be tomorrow's problem. Coal was a solution to deforestation. We were cutting down trees for our wood, but coal came along and was a better fuel and cheaper and closer to market. So that slowed deforestation, and in fact, forests grew back, which is great news. But today we see coal as a threat to those forests, so that's a challenge we have to deal with. And there are other examples. For example, we used whale oil as an illuminant for lighting, and we started running out of whales. Whales became depleted and expensive, and we switched to kerosene. Kerosene as a higher performing, brighter, cheaper, better fuel. And then whale populations grew back as we started to use kerosene. But today we think of oil as a threat to whale populations because of offshore production. So those are examples where the fossil fuels, coal and oil, were actually solutions to environmental problems, but then at scale become their own kinds of problems that we want to deal with later, in particular looking at the CO2 emissions. So we have this transitions, there are a couple lessons, there are a couple similarities in the patterns we can look to, and that's a reminder for us that we better get moving because it can take a while, and whatever solution we're implementing today at scale could be a problem 100 years from now.
So in the book, you mentioned 6 demographic trends that drive our energy demands: population growth, economic growth, urbanization, motorization, industrialization, and electrification. On top of that, we're dealing with 3 major technological trends: that society is becoming more efficient, everything is becoming more information intensive, and there's a rise in the decentralization of energy sources. Can you tell us a little bit more about these trends and how they're driving us toward a new energy future?
Yeah, these trends, which are really demographic and technical overlaid with this grand challenge of how to increase energy access while decreasing the impact, mean that everything is changing for energy at once. We're changing how much we use because there's more of us and we're getting richer. We're changing how we use it because we're moving from farm to factory, from rural areas to cities. And that means we're changing the forms of energy we use and also the quantities we use. We're also looking to decarbonize because of policy concern about the future. So we're changing how much we use, what we use, and what we use it for. That means everything in the energy system is changing. The technical trends give us some reasons to think that it might work out for us because the rise of information intensity and the decrease in energy intensity coupled together means we're becoming more efficient and smarter with how we use energy. And the decentralization means there's opportunities to integrate different kinds of technologies. So these give us opportunities. And then at the same time, we have to do this within the wrapper of not only reducing the impacts for the 6 billion people who have energy, but increasing access for the billions who don't. Sometimes in the West, where we have universal energy access, we really focus on the impacts, which is a good thing, but we should also focus on increasing access for those who don't have it. And just telling them that they don't get access to energy because they're poor doesn't seem moral or humane. So we have to solve both of these at the same time.
Mm-hmm. So what are some of the major concerns you hear most often about the energy transition? And how do we begin to address them? And Greg, feel free to jump in here.
The different challenges, there's all sorts of challenges, and Greg will correct anyone that's able to answer them. But I think most of the challenges aren't fundamentally technical, although there are a lot of pathways, a lot of run ramp left for technical improvement. It feels like we have a lot of technological solutions in hand for a low carbon future, but we don't have the infrastructure, or they cause social disruption because different kind of people will make money from that future, or jobs will be lost in one sector like coal mining. They might grow in another sector like solar installations, but that social disruption can be very impactful. So I feel like we have a lot of challenges, but they're mostly non-technical. They're mostly behavioral, economic, political, cultural, and those things all together create the technical roadmap for people like me, which is, okay, how do I use technology to solve those non-technical problems by driving down the cost or increasing the performance of solutions, for example. But there remain all sorts of hurdles, that's for sure.
Yeah, I would reiterate what Michael's saying. I think one of the biggest challenges is there's a huge disconnect between a lot of the technical advancements that are happening in energy right now and the policy decisions. As a lot of us have seen, this grand challenge of it's either we continue with fossil fuels and provide energy, or we're going to renewables and we're a Green New Deal. I think there's a lot of complexity that's missed in the debate. And I think that's why Colorado School of Mines is a great university to start participating in that, because we have such a breadth of experience and knowledge around some of these technical solutions, but we need to start bringing those into the policy world so that the policymakers also have a more nuanced understanding of what the energy transition looks like and the complexities that it brings.
So, Mines is a leader in earth resources with strong ties to the mineral and oil and gas sectors. How are we facilitating an integrative approach to the technical and policy challenges related to the energy transition? And why is Mines and the Payne Institute the best partners on this issue?
I think, when you look at Colorado School of Mines, people think of the mining engineering, the number one mining engineering department in the world. We also have, obviously, a long history in petroleum, but we also have world-class programs in renewable energy and mechanical engineering and water. All of these things, as Michael well points out in his book, are interconnected. And we're a small university, but we're very engineering focused, and we have the opportunity to work across these problems in a way that, quite frankly, other universities don't. And so as the energy transition continues to happen, Mines can play a leading role in leading some of those conversations.
Great.
And I would say that as someone who works at a different university, the University of Texas, and also now in Paris, France, at one of the largest energy companies in the world, my view is that Mines is a leader for the reason that you just heard, but just sort of a history and legacy of expertise, which really can be leveraged for a lot of our solutions moving forward. Wind turbines might feel different than mining, but wind turbines depend on mining in many ways. And geothermal energy and other renewable sources certainly depend on below-ground expertise that Mines has in abundance. So I think Mines has the right kind of skills we need, and it's training the students that companies like ours need to hire in the future. So we see them as a great prospective partner for them.
So, Michael, in Power Trip, you suggest that we need a combination of new production, increased energy access, smarter solutions, and a cultural emphasis on efficiency and conservation. What innovations do you think need to happen to help solve our energy challenges?
It's a great question. I think there's all sorts of technologies we need to get better at, and these are sort of the obvious ones in the news. We need to make wind better, and solar better, batteries better, you name it. So all of that is happening and should happen, and it'd be great if the pace picked up. But the challenge that I find the most vexing and the most difficult for society is around low-carbon fuels. We mostly know how to decarbonize the power sector. You shut down coal and replace it with gas, and then eventually you'll shut down gas with wind and solar and nuclear, or you'll add carbon capture and offsets and other things. So we need to clean up the power sector. But that's mostly headed the right direction in a place like the United Kingdom and the United States, where carbon dioxide emissions from the power sector have been dropping, such that transportation now is a bigger emitter than the power sector. So we kind of know how to decarbonize the power sector. We just need to do it at a faster rate and more extensively.
Mm-hmm.
Decarbonizing mobility can be done by electrifying, at least for light-duty vehicles. We can get our smaller cars electrified, and then when we decarbonize the power sector, that solves the transportation sector's emissions, so that's kind of cool. But what do we do about the heavy-duty shipping, or the big trucks, and marine shipping, and aviation, and the chemicals industry, and cement and steel, some of these harder to electrify industries? That remains vexing, because I think those industries are going to need fuels, because fuels can carry heat at a much greater reliability and cost and greater density. So they require a lot of smaller rights-of-ways and less land and that kind of thing. So fuels have a role in the future, but we have to take carbon seriously. So how do we decarbonize fuels? That's the most vexing problem. And in a company like ours, where we sell electricity, gas, and services, but we have a mission to decarbonizing the gases is critical. We sell gas to people who burn it and therefore emit CO2. We also need to decarbonize. We've decarbonized already. We've cut our emissions 50% in 3 years. It's really incredible. For an energy company like ours to decarbonize 50% in 3 years, I can't think of any other company of any magnitude in the world that has done anything close to what we've done. But that was also the easy 50%. Now we need to do the hard 50%. But the easy 50% was we sold coal plants and built wind and solar. What do we do about our gas networks and our gas power plants? So there are a couple options. One is you can replace that methane with biogas. That works fine, although biogas is limited in scale. You start to hit some limits of what you can do there. Maybe you can electrify a little bit to reduce how much gas you have to use. Maybe you can do efficiency at a wider scale to, again, reduce how much gas you use. Then maybe you can do synthesized methane from hydrogen or ammonia or something like that for part of it. And then maybe you do conventional gas with capture or offsets. So that's kind of the strategy. Electrification, efficiency, biogas, synthesized gas, gas and capture, or gas with offsets. That's how you get to zero carbon gas. But that's easier said than done. That's our harder problem on the research side, not just for us as a company, but for the world, because the world wants fuel in addition to electricity, because electricity doesn't quite get us all the way there.
So Greg, how do we begin to cultivate that emphasis on efficiency and conservation while acknowledging and being respectful of our past and the carbon-intensive industries or resources that have spurred energy growth and opportunity around the world for so long?
I think that's a great question, and it's really, one of the challenging questions that we have right now, because I think we see a lot of progress happening, but we see a lot of division as it relates to the conversation. So from my perspective, we need to cultivate a conversation to address these issues and bring together some of the policymakers and some of the people that provided those traditional energy sources and have them start having constructive conversations. I think we see at a national level and even international level, there's a lot of rhetoric going around that's maybe disconnected from the incredible voices of people like Michael, who have such a great understanding of the complexity and the technological advances that we're making. And we need to connect those dots. And I think, again, that's where minds can play a really leading role. Is we have this expertise on the historical fossil fuels, which as we know, will continue to play a leading role, but we also have these other experiences, and we need to bring those into the public sphere so that we can contribute our knowledge and our technical expertise to that conversation.
So really having better conversations.
That's my opinion. I think that's what we're trying to do at the Payne Institute, connect the technical expertise of the university with the public sphere. As Morgan Bazilian, the director of the Payne Institute, always says, the rest of the world, so to speak.
Mm-hmm. Michael, in your book, you write, ultimately, to solve our energy challenges, the world needs the next generation of innovators. We need them now. How do you think the energy transition impacts students and the way we approach how they're taught in the classroom? And how do we prepare them for careers in industries that are rapidly changing and may even look drastically different 20, 30, even 40 years from now?
Well, I'll tell you, the students are ready for this. They are more ready than faculty are to teach them, or universities are prepared to facilitate their multidisciplinary research, or even companies are ready to hire them. Younger people see this as a multi-decade generational challenge, kind of like my parents' generation saw the Cold War. The Cold War, by the way, looked intractable. It looked like an unsolvable problem, but we solved it. And for a lot of people, climate change looks like an unsolvable problem, but I think we'll solve it. So I think in the classroom, we have to be more multidisciplinary with our teaching. We have to teach policy and economics along with engineering and sciences. My classes include thermodynamics and basics on policy and markets. I think that we as a company need to be more specific about what we're doing so that people want to hire us. And I think research programs need to weave these different topics together because energy is not in one discipline. It's in all the disciplines. And that means funding agencies like National Science Foundation and U.S. Department of Energy need to recognize that and sponsor it. And faculty need to build the right collaborative teams across those sectors so they can tackle the problem effectively. I think that means the post-World War II way we designed our education and research structures at top-tier universities really isn't going to work for this next problem. And I think it's also not just climate change. I think the same could be said for security and foreign policy and healthcare and other complex problems. We're going to have to rethink education. I don't think that means universities aren't relevant, by the way. Some people say online education won't go and make universities irrelevant. I think actually universities are more relevant, but we just have to configure them so they're really posed the right way for the problem.
Right.
Yeah, I agree. I mean, I think that this challenge of silos that exist in a lot of disciplines is problematic as it relates to energy, but a lot of different areas of study. And I think Mines is, with this emphasis on earth, energy, environment, and the way they're talking at the next 150 years is well positioned to be a kind of university that's looking across these disciplines and preparing the future engineer so that they can address not just the scientific or the technical problems, but also the policy challenges and other aspects.
Well, I think that gives us a very hopeful outlook for the future.
Yes, thanks for having me today, Ashley.
Yeah, thank you. Thanks for joining us today, Michael.
Thank you. I appreciate you having me on the show.
To keep up with the latest news and discussions related to the energy transition and public policy, visit the Payne Institute's website at payneinstitute.mines.edu. And to learn more about Colorado School of Mines and how we're leading the energy future, check out our website at mines.edu. Thanks for listening.